So as you can see, just so the area increasingly distorts towards poles, but the shapes are remain the same. So very importantly, the traverse aspect can preserve the north and north and south. Uh, so that's why we have UTM. UTM is like 60 projections. Each with entanglement along different
Meridian.
meridian. So here's first record. It's about comparative projection, and you can see this one's WGS 1984 web Mercator, and so you can see the circle like near the pole area. It's getting bigger, but horizontally there's nothing change. That means the conformal uh, web Mercator projection has a lot of impact uh, as the alongside the longitude line, and there's nothing a significant change uh, alongside the latitude. Uh, this one is called Cynical Eco Area map. So preserves the area, but not the shape. And the shape is increasingly distorted toward the poles. If you measure, if I do the same measurement again, you can see the distance is much shorter than before, which is the 86 miles. Yes. So this one is called Lambert conformal conic. So they have conformal and conic. That means the projection has both of the characteristic of this method. First of all, conformal. That means, as I mentioned, like there's distortion alongside the longitude, but not the latitude. And and you can see the shape also preserves. And also, if you add the conic, that but to be noticed, this projection only, I mean, they preserve distance along the standard parallel. So like, preserve distance like this. So it can somehow reduce the the impact that is brought by the different projection. So this one, if you want to measure distance, pretty accurate. So you can use the conformal conic. There's one more thing probably want to notice. So it's called
Geodesic.
it's called geodesic line, and that's the most accurate method if you want to measure for shortest distance between 2 points on the Earth. And because the measurement from New York to London, see, is roughly trace this
Secant.
the secant line. Uh, so there's going to be almost zero distortion, but because the Beijing to Sydney or route to Naburi, is crossing a very vast area, so uh, they have a lot of distortion. Another important information I want to tell, like the true equidistant projection can still have some uh, distortion because it's only preserved the measurement passing through the one point, which is a pole, I believe, because I checked the map. So there's another part of the exercise called perspective. Perspective is defined by this, the light source of the map. So it's like the second concept of the projection, I would say. And I finished all the steps, but I could have just clicked the pictures. I mean, it already give you the results. So first of all,
Mnemonic.
it's called mnemonic. Uh, there's a light source from inside. See from the inside, and mnemonic has one of the biggest distortion. I'll show you. So you just select North Pole mnemonic. Uh, you can see it's not just the shape, also the size being like significantly changed. So it's not really good. And if you change to osteographic, you can see it's a lot better. It's specifically the shape's been preserved, but the rest of the size still not really as accurate as we can expect it. I also notice like alongside the latitude, the size of the ball hasn't changed, just like the web nomenclature, and so that's a still graphic, and that one's orth orthographic,
Orthographic.
orthographic, and if you apply over here, so like the light source from infinite, and you can also change the primary values, and you can just have you can render a globe to a 45-degree angle. It's just that's really important. So here's another very important uh, method of reducing distortion. It's called aspect. So aspect means like uh, so if you want minimize distortion on one area, so like in this video, so Antarctica, so you just change the aspect according to the scenario, like aspect, I can explain it as like localize the distortion by changing the aspect. For example, like you can look, so like the way it wraps the earth uh is different based on the purpose of the specific area, and like Hawaii, so you can see like it's called oblique projection can make sense, based on the specific location and the shape and distortion of the land. So yes, that's so called the aspect.